Welcome to today's session, where we are going to break down one of the most common and sometimes frustrating exceptions you face when automating with Selenium, the no such element exception. There is something almost every automation engineer encounters, but the challenge is that many people only know how to fix it technically using weights or better locators without understanding why it even happening at the first place. So in this video, we are going to focus only on the concepts. We will not look at coding in this video. No fixes, no Java examples. There will be there, but it will be in the next session. Today's goal is to understand the root causes deeply so that the moment you see this exception in the future, you instantly know what category the issue falls under. Okay, so let's begin. Let's understand what this exception really represents in Selenium world. Whenever you write something like find element, Selenium sends a command to the browser saying, please search this current DOM for an element that matches this locator. Okay. So now the key phrase here is current DOM. Selenium does not wait, guess, or assumes anything. It looks at the DOM exactly at that moment. If the browser checks the DOM and does not find the element, even if it appears a fraction of a second later, Selenium immediately throws this no such element exception. So conceptually, this exception simply means this. The element was not present in the DOM at the time Selenium searched for it. This could be because the element actually does not exist, or it might be there, but it has not loaded yet. Or maybe the locator is incorrect. Or maybe Selenium is searching in the wrong DOM context entirely. And that's why this exception is so tightly tied to timing, DOM structure, and framework behavior. How Selenium searches elements. To understand the exception better, it helps to know what happens internally when Selenium searches for an element. When Selenium runs a find element method, the following happens behind the scene. First, Selenium talks to the WebDriver. Using the WebDriver protocol, it sends a JSON command like find an element using CSS or XPath. Second, browser processes the request. The browser takes that command and inspects the DOM exactly as it exists at that millisecond. Third, browser sends back result. If found, Selenium gets a reference and wraps it up as web element. If not found, browser sends back an error. Selenium throws no such element exception. It is very important to understand that Selenium never waits by default. It is immediate. So, if your element is loading half a second later, Selenium doesn't care. It checks only once at the precise moment of search. This is the conceptual foundation behind every cause we are going to explore. Where this exception commonly occurs or appears. Before we go into the cause, it's good to visualize where you are most likely to encounter this exception. You will see no such element exception in a lot of areas like login forms, search bars, product lists, modals or pop-ups, drop-down menus that expand, dynamic dashboards, pages that fetch data via APIs, Why? Because all of these areas rely heavily on JavaScript, animations, or dynamic rendering. For example, a pop-up might appear 1 second after a button click. A product card might load only after an API fetch. A login field might be hidden behind a transition animation. So this exception is a sign that Selenium and the browser are out of sync, either in timing or in the structure. There are 7 major causes for this. Okay, when you get a no such element exception, it boils down to one of these 7 categories. First one, wrong locator. Second one, element not rendered yet. Third one, dynamic element IDs. Fourth one, frames or iframes. Fifth one, shadow DOM. Sixth one, page renderers or DOM replacement. Seventh one, Angular React SPA async loading. So these 7 causes cover almost every real world scenarios. So what you're going to do now is take each one, break it down conceptually, and understand why it leads to this exception. Cause 1, wrong locator. The simplest and most common reason is using a locator that doesn't match the actual element. This could happen because you typed the wrong ID, you assumed the locator without checking. Developer changed the HTML structure. You are pointing to the wrong element in the similar group. The element's attribute doesn't exist anymore. In other words, Selenium searches for something that literally doesn't exist in the DOM. This is why the first debugging question is always, is your locator actually correct? A large part of no such element exception arises simply because we automated the wrong selector. Cause 2, element not rendered yet. This is the second most common conceptual issue, timing. Selenium is fast and modern web apps are slow, especially with JavaScript-driven rendering. Element might appear after API calls, loading spinners, animations, fading transitions, conditional logic. Okay, so when Selenium checks the DOM, the element is not there yet, but it will appear a moment later. Conceptually, this cause is about render timing. Selenium is too early and the browser isn't ready yet, which will result in no such element exception. Cause 3, dynamic element IDs. Dynamic IDs are extremely common in modern UI frameworks. React, Angular, and many enterprise UI generates IDs like input 12345 or element abcd -xyz or autozen 98697. These are just examples. So it will generate these random enterprise random IDs. So these IDs they change on every reload on each session. So if your locator uses these IDs, Selenium will look for an ID that used to be correct, but that no longer exists now. So conceptually, this is about unstable HTML attributes. If the identifier changes, Selenium is searching for a non-existent element, and the exception is guaranteed in that case. Cause 4, frame iframes. So this is one of the most overlooked causes. Whenever an element lives inside an iframe, the iframe has its own DOM, completely separate from the main page DOM. So Selenium always starts in the main page DOM. So Even if your locator is correct, the element is visible to Selenium because Selenium is simply searching in the wrong DOM tree. That is like looking for your house keys in the wrong room. Not because the keys are missing, but because you are searching in the wrong place or wrong space. So conceptually, the cause is all about context switching. Selenium must be pointed to the correct DOM before searching. Cause 5. Shadow DOM. With the rise of web components, many modern apps, including Chrome's own setting page, use Shadow DOM. Shadow DOM is like a mini DOM inside the main DOM, but the content is encapsulated. It is hidden behind a shadow root boundary. Selenium's default element searching mechanism does not cross that boundary. So if the element lives inside a shadow root, Selenium will never find it unless explicitly accessed through the shadow host. So conceptually, this is about DOM encapsulation. The element exists, but Selenium cannot reach it through normal DOM traversals. Cause 6. Page re-renderers DOM replacement. Another conceptual cause is that the DOM itself is being dynamically replaced. In many SPAs, drop-down selections, filters, or button clicks cause the entire DOM subtree to refresh. The element might exist for a moment, then disappear, and then reappear. So when Selenium performs a search, it could be searching during a render. The element might temporarily not exist. The underlying node might have been replaced. So conceptually, this cause is about DOM volatility. The HTML is not stable. It's continuously being rebuilt. Cause 7. Angular React SPA's asynchronous loading. Single page applications like Angular and React perform a lot of asynchronous operations. Elements only appear after state updates, API responses, virtual DOM reconciliation, component mounting. This means the HTML structure is not ready immediately. So Selenium looks for the element before the framework finishes its internal lifecycle. So conceptually, this cause is all about asynchronous rendering. The element appears only after the framework logic finishes. Additional contributing factors. So these are not primary causes, but they amplify the issue. Slow internet, heavy UI animation, lazy loaded components, conditional visibility, hidden elements loaded only when scrolled. All of this affects when the element becomes available. The key point is the DOM is not always predictable. Selenium must deal with real world delays. So, to summarize the entire concept, no such element exception happens because at the exact moment Selenium checks, the element simply isn't there in the DOM. So either it never existed, or isn't ready yet, or is hidden behind some special DOM structures, or is inside a different DOM like iframe or shadow, or appeared only after asynchronous logic or operations are complete, or the locator itself is wrong, and the locator you have used, that itself is wrong. So understanding this gives you clarity. Instead of guessing, you will know exactly where to look when debugging now. Okay. In this video, we have covered only the why. Okay, fixes, weights, frame handling, shadow DOM access, and stable locator strategies. All of that will come in the next video. But now you have the conceptual foundation. Once you know why the exception happens and how to fix it, becomes very easy or simpler, and more logical, I would say. So there'll be next part for this where We will be discussing each and every causes, okay, and I'll show you how do we handle them programmatically. Okay, so we can do a hands-on on those causes and fixes, and we can do it together. So till then, thanks. Let's see you in the next session.